Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains the corrections we need to make for sample size and why we need to make them. Let's get started. To illustrate the corrections that we need to make for sample size, let's look at a data set that we've seen previously. The data set for the ages of Best Actress winners for the Oscar. So we're going to assume that these ages are normally distributed with a mean value of 36 and a standard deviation of 11.08. So the question we're asked is, what is the probability that one randomly selected Best Actress winner is over 35 years old? Well, if we are, almost said lazy, if we're resourceful, we're going to use StatCrunch. And so when we do that, we just put the mean and the standard deviation value here into our normal calculator. And then we put in here for the probability section that we're going to have the probability that we're greater than 35. So when we do that, we hit compute and out comes our actual probability, okay, which we see here is about 54%. Now, what is the probability that 15 randomly selected Best Actress winners are over 35? So the same problem, but the only change, the difference is the sample size is increased from 1 to some number greater than 1. In this case, 15. So again, we go back into StatCrunch, and we're going to find that our probability is now almost 64%. Notice we had to make an adjustment for our standard deviation, okay? Because our sample size there is greater than 15. Excuse me, our sample size is 15, which is greater than 1. So because it's greater than 1, we have to take that standard deviation value they give us and divide by the square root of the sample size. This gives us an adjusted standard deviation value to put into our normal calculator in StatCrunch. If you don't put that in, you can see you're going to get a different number coming out for your probability, and you'll get this part of the problem wrong because you didn't adjust your standard deviation like you were supposed to. Let's look at the same problem again, but this time involving Best Actor winners. So here, feel free to stop the video, get into StatCrunch, load up the Best Actor data set, and see if you can answer this question here using StatCrunch. What is the probability that one randomly selected Best Actor winner is under 35 years old? Then when you solve the problem, come back and we'll see how well you did. Okay, let's see how well you did with that. So in StatCrunch, you should have gotten the normal calculator and put in the mean and the standard deviation values that you see there in the problem statement. And then we want the probability that we're under 35, so it's going to be less than. And then we just hit compute, and out comes our probability, 15.5%. Now, what is the probability that 12 randomly selected Best Actor winners are under 35 years old? Okay, so again, stop the video, work this problem, and then come back and we'll see how well you did. Okay, let's see how well you did with this. So the normal calculator in StatCrunch, okay, should look like this. Here's your mean value, 44.1. Notice we adjusted our standard deviation value. We have to adjust our standard deviation value because we've got more than 1 in our sample size. We've got 12 in our sample. So that means we're going to have to make a change in our standard deviation value, okay? And the change we make is we take the standard deviation value they give us and divide by the square root of our sample size. In this case, that's 12. So we take the 8.98 divided by the square root of 12, and that gives us 2.59. And that's the number we stick in to our standard deviation field in StatCrunch. You can see the probability that comes out is really, really small. So yeah, almost a certainty that the Best Actor winner is not going to be under 35 years old. You may be wondering, why do we have to make this adjustment to the standard deviation? We're not making any adjustment to the mean value, but we're making an adjustment to the standard deviation value. Why is that? Well, recall from a previous mini lecture that the standard deviation is a biased estimator. That's why we're making an adjustment to the standard deviation, to account for the bias that's inherent in this estimator. So because it's not targeting the population value, we have to make an adjustment to compensate for that bias that we see in the estimator. This also explains why we don't also adjust the mean value. Okay, because remember, the mean is an unbiased estimator. So there's no bias to compensate for in this estimator, and that's why we can just take the value as is, regardless of what our sample size is, because the mean is an unbiased estimator. So we don't need any adjustment to compensate. Now, here's a little trick. If you're using a calculator on your computer to make your adjustments to your standard deviation, just copy and paste the entire value into the field in StatCrunch. Okay, so if you go into your calculator, there's usually some copy feature, or you can just select the value there, and then on your keyboard select Control-C, and then you just go into the field in StatCrunch, hit Control-V, and it'll just paste that value right in there. You don't have to worry about missing a digit here and there, or having some other error in translation from the one field to the other. You can just instantly copy it over, really quick and easy. So, however, if you do use this trick, make sure you select everything in the standard deviation field before you paste a new value into it. Otherwise, what it does is it just tacks on whatever you didn't select, onto the value that you do select. So it actually gives you a different number. So make sure you select everything in your standard deviation field before you paste a new value in. One final word about corrections that we make for finite populations. So we've seen before that when we're sampling without replacement, so we have dependent events, our sample size is less than 5% of our population size, then we could actually use the independent calculation to count up the total that we're going to use for a probability, the whole part of the fraction. Well, that's the same thing as making the adjustment in the standard deviation like we've seen in this mini lecture. So we just take that standard deviation, divide by the square root of the sample size. If, however, our sample size is greater than 5% of the finite population, then we need to make an additional adjustment to the standard deviation, which you see here. So not only are we going to divide the standard deviation by the square root of our sample size, but we're going to multiply it by an additional correction factor, which you see here, square root of n minus n over n minus 1. This is an additional factor to weed out the additional bias that we get from having our sample size. Remember, the standard deviation is a bias estimator, and it's because of the bias that's inherent in the estimator that we have to make these corrections. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.